In this video, we will talk about what present value is. And I want to motivate this with an example. So the situation's similar to the example that we looked at in the last video, where Dorothy has a new job that's paying her $80,000 per year, and her salary increases by $5,000 per year. She invests all of her income into some account and earns 4% interest annually. She receives income and interest continuously, and she starts working on February 1st, 2020. The question is, what are her earnings from February 1st, 2020 through April 1st, 2020 worth to her at that starting point on February 1st, 2020? Round to one decimal place. So this is asking a question about a hypothetical question about what future earnings, what the amount that she'd earn over these 2 months would be worth to her at a starting point now. So we call this a present value. It's the present value. And in parentheses, I'm going to put of future earnings. It's asking how much would these future earnings be worth to her now? All right, so how do we measure that? Okay, so I want to give a definition. So we said we're going to call this the present value. The present value. All right, so let's underline this. And present value, we'll denote it with PV. So the way we're going to measure present value is we'll say that this is the amount of money you'd need to deposit now into the account and just let it do its thing. So which means, and just earn interest. So you're not adding more, you're not adding any income to it. It's just some lump sum of money you're going to put into the account, deposit it, and just earn interest for the rest of the time period. 2, for that to end up equaling the future value of the income stream. All right, so let's compute the present value for our example. So in our example, we want to know the present value. So let's let PV be the present value. I'm just going to call it PV. And then this unknown quantity is going to get deposited, and it's going to earn. It was 4% interest. It's going to earn 4% interest compounded continuously. That was the interest rate per year for how much time? So we saw in the last video that the amount of time was 59 days for these 2 months, for February and March. But we convert that to years by dividing it by 365. So it's 59 over 365 of a year. Okay, so that is how much time this unknown present value would have time to earn interest. Okay, so then the present value, when we multiply it by e to the RT, so we're using the PERT formula. It's just the P is present value now. So P times e to the R times the time, and I'll just write time period, however long the time period is. This needs to be equal to the future value. That's what the definition of present value says it should be. We're depositing some amount of money that's earning this interest rate over time. So the value of that is given by this PERT formula, where P is just present value here. So that's why I'm writing PV instead of just P. And whatever that quantity ends up being, I need that to be the future value. That's the definition of present value. Okay, so I'm now going to write this formula that we just wrote down in a more general way. So in general, this will look like present value times e to the r. And how I'm going to denote my time period is I'm going to do my ending time, B, minus my starting time, A. And that is equal to FV, the future value. And let's box this. So that's going to be true. This equation is going to be true in general, connecting present value and future value. Okay, so now let's plug in our specific numbers from our example. Present value times e to the interest rate is 0.04. And then for my time period, it's 59 over 365 of a year. That's how much time that it's going to earn interest for. And this needs to be equal to the future value. But the future value we computed in the last video. The future value was 13,038.9. At least it was approximately that when I rounded it to one decimal place. Okay, so this equals PV times e to the 0.04 times 59 over 365. Let's try that 65 a little better. 365. Okay, and let's scroll it down. So now I could isolate PV. I just have to divide by this e term. So PV equals 13038.9 divided by e to the 0.04 times 59 over 365. And I'm going to round that to one decimal place as well. And I get 1,200. Sorry, no, this should be 12,000. Whoops, $12,954.9. And that's my present value. So going back to what we got in the last video for our future value, in the last video we saw that the future value, in other words, it was how much money we would have in the account after 2 months, and this money is coming from the fact that we had income from the job, as well as we start to put money in over time that's earning interest. This was how much it's worth over 2 months, at the end of 2 months, about $13,000. The present value, the number that we got, was a bit less than that, 12,900 something. Conceptually, this represents how much money we would have had to put in the account so that if we did nothing with it, if we added no more money but just earned interest, it would what the value of it would end up being by the end of that 2 months is the same as this number, same as this $13,038.90, same as the future value. All right, so okay, I want to make a note of something. So note that the present value equaled the future value times, when we divided by this e term, I could also think of that, if I move that e term up to the numerator, as being a negative exponent. So FV times e to the negative 0.04 times 59 over 365. Okay, and then I'm going to remember what was our future value from the last video. Okay, so we have PV on the left, and on the right, future value is an integral from 0 to 59 over 365 times, in the integral 80,000 plus 5,000 t times e to the 0.04 parentheses 59 over 365 minus t. That's what future value was from the last video. So when I multiply this whole thing, let me put a dt. When I multiply this whole thing by e to the negative whatever, that's a constant. So when I multiply that by that constant, I can move that constant inside the integral and get e to the negative 0.04 times 59 over 365. And then we have a little bit of cancellation. We'll end up with this integral 0 to 59 over 365. we still have the 80,000 plus 5,000 t, but this positive 0.04 times 59 over 365 and this negative 0.404, sorry, times 59 over 365, they will cancel, and I'll be left with e to the negative 0.04 t. Okay, so the reason why I'm doing this is this will give me another way to write present value as an integral. In general, the present value of some income stream that is being deposited into an account earning an interest rate is going to be equal to the integral from a to b. Notice at the front of what we had, we still had the income stream formula, r of t. But then the exponential part changes. It's e to the r times a minus t, it turns out, dt. Where r is the interest rate, that was 0.04. The a in my integral above, the starting time was 0. And if we did 0 minus t, that's just negative t. And that's how we had this thing above. Okay, so I'm going to highlight this formula. This is another key formula from the section. I didn't need to use this integral formula in this example because I already knew the future value. But if I don't already know the future value, I can just use this formula for the present value to get it a little bit more directly. But just as a reminder, we can also compute the present value as we did above if we knew the future value, or if maybe we just think it's easier to get the future value, using the fact that present value times e to the r times b minus a. So that exponential part is factoring in the interest rate as well as the time period that this present value thing would have needed to be deposited for, and that should be equal to the future value. Oops, and let's highlight that. So I can also get the present value if I compute the future value first, and then I divide this exponential term over to the right-hand side. So the second formula is definitely useful in situations when I already know the future value, like we did in this example. Alrighty, so in terms of our goals for this section, we have finished our last goal, which is talking about what present value is and how we can compute it.